In-case forensic is a fantastic tool for forensic analysis. In this demo, I only want to show you how do we use in-case to visually see file systems we covered in the lecture, for example, FAT system and NTFS. So in this demo, I want to show you the FAT system. How do we visually to see what's component inside of the FAT system? I have already prepared a case called case 1, and then I move on to the evidence. In this case, I have a couple of images loaded into this forensic case, but the first image is a FAT12 system. So I open up. Don't worry about the in-case GUI interface and all that. We will discuss this detail later. But in this demo, I only want to focus on how to study system. So this is the tree structure here, and then first let's move on to a disk view. If you recall, I used a disk view before to show you how to see a mass boot record. But now I look at the disk view from this image. And again, this image is a FAT12 image. Okay, and you can see the first one is red. Okay, that's the first sector in red is a boot record. And then followed by this one. If I click 1, this is the FAT table. And the 2 is a backup. The backup of FAT table, so FAT1 and the backup FAT table. The green one, those are the content for the root directory. So all the root directory content is in this green this green boxes. Each box is 512 bytes, and then the green, the blue one, those are currently allocated data, the sectors. And then the gray ones currently is not in use. It's just a historical data, garbage in that. Okay. Now let's move on to examine the root directory. If you recall from this week's lecture, you know the directory's content is for his children. Basically, is for a file residing in this directory or subdirectory reside in this directory. Each entry uses 32 bytes to contain information, including the file name and extension, what type is the file, either is directory or file, and what is the first cluster's address, which is important, right? And then and also the length of the file, and then date and time. So each entry uses 32 bytes to represent one entry. Now we look at the content here, because now I click on the green one, click on green to look at the root directory, and then I change that to hex view. Okay. So if you look at the offset, you see I have actually adjusted this the pen to be 32 bytes long for each line, because it's from 000 to 31. This is a start from 32. So each line is 32 bytes, which means I line up correctly. So each line represents one entry in this directory. In one entry. So for example, the second line here is called file 4. Now you can see that the first 11 bytes is it is a file name, and followed by other information. We said the first cluster information is reside in byte 26 or 27, which is this one, byte 26 of 27. And since this is Little Indian, so you have to swap those 2 bytes. So it's read as 0002. It means the first cluster is 0002. And once the FAT gets this first cluster for this file, and then it will use FAT table to represent, to find the chain of other clusters. So here is the first cluster information. It's very important. And when you get chance to use, in case if you want to practice this exercise, make sure here each line is 32 bytes. That's critical. And also in the class, I talk about the file, if in FAT system, if the file is deleted, the file name's first character changed to E5. So if you see the file's name started with E5, like for example file 1, this is deleted. Okay, you will see many of those E files. Those are all deleted file. The first character of the file name changed to E5. So you will see the whole content from this root directory, because every file starts from the root directory. You will see the whole content of a root directory. Okay, now let's go back to the evidence here. If I look at here, okay, if I choose one folder, let's see, if I choose this folder, oh, this folder has nothing. If I choose a folder here, now you can see which folder I choose. I choose that fs event st folder. Okay, that one, it you see the content. See, this is the folder, and the content has a dot and a dot dot. And this is the way, in case you, or other forensics tool used to recover deleted folder, because they just look at the content. If they find the dot and the dot dot, those are the ones in the content. Then they assume, oh, this might be a directory, because directory always has those two entries in there. Now, previously, when we look at the root directory view, we analyzed file 4. It's in the second line, right? This is file 4, has a first cluster as a 00, first cluster number is 0002. Let's see if that's correct, whether this file 4 and starting cluster number is 0002. So we go back to here, find file 4. So look for file 4. Actually, this is a picture, and then in case very smartly to show you the picture view already. And if we look at the hex, and then you look at bottom, this says this is file 4, and then here CL means cluster. So the starting cluster is cluster number 2. So that's also match for what we're seeing from the entry, from file 4's entry. Okay, that's it for this video.